Hello everyone. In this video, I'm going to talk about Lewis structures and how to draw Lewis structure of compounds. If we know Lewis structures or a structural formula, we can talk about molecular shape or geometry of compounds. First assumption or first requirement for this methodology I'm gonna talk about that is knowing number of valence electrons for each element. So we need to know number of valence electrons for each element we are going to work on. Number of valence electrons is coming from group number. So you do not need to draw or write any electron configuration or orbital diagram. So group number, it would be same as number of valence electrons. So please memorize that one. Number of valence electrons, it would be same as number of group numbers. What does that mean? Assume that we are going to talk about hydrogen. Hydrogen group 1. So we have only one valence electron. One valence electron. If we are talking about carbon atom, carbon group number 4, we are going to have 4 valence electrons for carbon atom. It would be same for any other elements, like let me write sulfur. Sulfur, you just need to look at the periodic table and you don't need to write electron configuration to find number of valence electrons. So easily you can say 6 valence electrons for sulfur atom as well. Right now, I'm gonna work on one method you need to apply. We need to work on one semi-method, we call that electron dot structure. Electron dot structure of elements. What does that mean? Based on this method, we are going to report valence electrons by dots. By dots. What does that mean? So please look here. When we say hydrogen, it has one valence electron. So I'm gonna write hydrogen, and I need to report these valence electrons by one dot. So I'm gonna write like this. So as you see here, I draw chemical symbol of hydrogen and I added one dot. It means we have one valence electron for this element. One possible question, can we draw like this or like this? How about that one? The answer is absolutely yes. You can draw dot in any side of element. So for each element, assume that we have like this element, we have 4 sides. So you can add electrons either on the top, bottom, left, and right. So all of them, we understand hydrogen has one valence electron. How about carbon atom? So let me draw electron dot structure of carbon atom. Carbon, group number 4, 4 valence electron. So I have to add 1 valence electron to each side. Please understand, first we need to add 1 valence electron to each side. Then, if we don't have any sides available, we are going to pair our electrons. What does that mean? Look at the sulfur atom. I'm going to say sulfur has 6 valence electrons. So I'm going to add 4 valence electrons for sulfur. Right now, I'm going to work on the remaining number of electrons. So 5 and 6. Again, when you are going to pair electrons, it doesn't matter what side you are going to pick for adding your electrons. So this one or any combination like this is acceptable for sulfur atoms. So 4, 5, 6 or any other forms. When we are going to work on this one, I'm going to ask you to please pay attention. One side you see pair electrons, one side you see only single electrons. So it looks for any elements we are going to work on, we may have either single electron or pair electrons. So for sulfur atom, we have two pairs and we have two single electrons. Right now, I ask you to draw electron dot structure of chlorine atom. So chlorine, I'm gonna draw electron dot structure for that one. Group number 7, so I need to draw 7 valence electrons for that one. So I'm gonna write chlorine group number 7, so 7 valence electron for chlorine. So let me write like this: Cl 1, 2, 3, 4, 5, 6, and 7. Again, I'm gonna make sure you understand there is some possibility to draw electron dot structure in other sites. So for this element, we have 3 pairs of electrons. 1, 2, 3. So I'm gonna write that one here. 3 pairs and only one single electron. So this single electron is here. One thing I'm gonna ask you, sometimes we call pairs lone pairs. So I'm gonna add another terminology, another term or terminology we apply for this concept. Some textbook call that pairs, some textbook call that lone pairs. I'm going to show you why electron dot structure of elements are important for us whenever we are going to work on Lewis structure. Because if you remember, chlorine atom has 17 electrons. And if we are going to draw or write electron configuration of chlorine, we are going to end by Ne3S2 and 3p5. So this is the abbreviated electron configuration of chlorine atoms. I'm going to show you how this electron configuration and orbital diagram is going to be related to electron dot structure. I'm going to draw orbital diagram for this element here. For s orbital, we need to draw one box, and for p orbital, we need to draw 3 boxes here. Right now, let me clean it up here. It's better. I'm gonna add electrons here. 2 electrons, 1, 2, and 5 electrons here. 1, 2, 3, 4, 5. Please look here. We have, if we look at this, we have 1, 2, 3 pairs of electrons, and we have only one single electron. And you see single electron here. So I just wanted to show you electron dot structure is going to illustrate or is going to represent the number of valence electrons based on electron configuration. So that is why this is one of the advantages of this method. How to work if we have compound, not element. So I'm gonna work on Lewis structures, and first I'm gonna work on diatomic molecules. Diatomic molecules. What does that mean, diatomic molecules? I'm gonna work on some example like H2, HCl, working on Cl2, oxygen, N2. I think that is enough if we are going to work on these examples as diatomic molecules. First, for diatomic molecules, hydrogen. I'm gonna draw hydrogen here. We have 2 hydrogen atoms and another hydrogen here. So I'm gonna add, let me draw the second hydrogen by another color. 2 hydrogen atoms, one with blue color, another one by red. Each hydrogen has only one valence electron. So I'm going to add one valence electrons for this hydrogen and one for another one. When we work on Lewis structure of molecules, we need to know that we are going to draw covalent bond. We are going to work on covalent bond. And based on other video, I already asked you to review that one and watch that specific video. I talk about the nature of covalent bonds. Covalent bonds, it means elements are going to share their valence electrons. So this hydrogen is going to share this electron, and red hydrogen is going to share these electrons. So covalent bond means we have two electrons totally for each bond. So two electrons for each bond, one from the first element, another one from the other elements. We are going to connect the single electrons. We are going to connect the single electrons. So we denote covalent bond by this line. This line, it has two electrons. One electron, as you see here, one electron over there. So each bond means two electrons. I'm gonna write now, call this bond covalent bond, and we may call that single bond, because we have only one bond between these two hydrogen atoms. This type of drawing, we call that Lewis structure of hydrogen, Lewis structure of H2. Right now, I'm going to work on HCl. HCl. We have hydrogen and we have chlorine. So one electron for hydrogen and 7 valence electrons for chlorine, because chlorine group number 7. So let me draw 7 valence electrons. As you see here, I put this single electron between these two atoms are gonna make a connection between them. So just connect the single electron. This one connected to that one. This bond has two electrons. Right now, this is another single electron. Whenever we are done with Lewis structure, we need to apply two rules. One rule is octet rule, and one rule is duet rule. What does that mean? I'm sure you may remember that octet means 8 and duet means 2. All elements, all elements must obey octet rule. All elements after drawing Lewis structure must make 8 electrons. Duet rule only applies for hydrogen. So all elements except hydrogen. So if we have hydrogen, we call that duet rule, 2 electrons. But other elements make 8 electrons. I'm going to count 8 electrons for chlorine. So please look here, 2, 4, 6, and this bond belong to chlorine because this is the shared electrons. There are shared electrons here. So 2, 4, 6, 8 electrons for chlorine. How about hydrogen? Hydrogen is going to count 2 electrons because this bond belongs to hydrogen as well. So when you are going to count electrons for each element, bonds belong to both elements. Look at the first example, hydrogen. So this bond means 2 electrons, belongs to hydrogen on the left and also belong to hydrogen on the right. So we need to remember the octet rule whenever we draw Lewis structure of elements. So this example is going to show you Lewis structure of HCl. I'm sure you can easily work on Cl2 as well. 2 chlorine atoms, 7 electrons for each one. As you see here, I put the electrons between two atoms because I'm going to connect them. So 7 valence electrons for another chlorine atoms, and you are going to easily connect the single electrons. We are going to count atoms. 2, 4, 6, 8 for the chlorine on the left side, and for the chlorine on the right side, I'm gonna say 2, 4, 6, and we are going to have 8 right now. So as you see here, for these molecules, we have single bonds, only one bond between them. How about oxygen? How about oxygen? So I have 2 oxygen atoms here. So let me draw oxygen, oxygen. Oxygen group number 6, let me draw 6 valence electrons. And this oxygen group number 6 as well. So let me draw 6 valence electrons here. Then you just need to connect the single electrons. This single to that single. And here we are going to make this single as well. So we had 2 single from each element, so we connected them. Let me draw oxygen atoms and their electrons here. As you see here, we have 2 bonds, so we call that double bond. We call that double bond. If you see 2 bonds between the atoms, you call that double bond. I'm going to count number of electrons. You may count like me: 2, 4, 6, 8. So 2 bonds means 4 electrons, and 4 electrons here, totally 8. So I'm sure you are going to count number of electrons for oxygen on the right: 2, 4, 6, and 8. Please understand, for oxygen, we call these electrons, let me call them lone pairs, or we may call them non-bonding lone pairs, because they do not make any bonds. They do not make any bonds. But these electrons make bond, so we call them bonding electrons. So when we have molecules, so you can talk about the bonding and non-bonding electrons. So in this example, these electrons, so they are non-bonding electrons, same like these ones. So for Cl2, we have 6 non-bonding pairs. 1, 2, 3, 4, 5, 6 non-bonding pairs electrons. For HCl, we have 1, 2, 3. 1, 2, 3 pairs. Please pay attention. We are talking about pairs, 3 non-bonding pairs, or you may say 6 non-bonding electrons. How about nitrogen? Let me finish this slide by working on the nitrogen. Nitrogen group number 5, 5 valence electrons. So 1, 2, 3, 4, and I'm gonna draw fifth ones here. Connect the single electrons. So one single here, one single here. So I'm gonna connect that one. So better drawing for nitrogen: 3 bonds, 2 electrons on the top for each one. I'm gonna count number of electrons. So please pay attention. This is the last example: 2, 4, 6, 8, and for this nitrogen, we are going to call that 2, 4, 6, and 8. All elements must follow octet rule, like this one. And here, I'm sure you call this type of bond triple bond. In chemistry, we have only 3 types of bonds: single, double, triple. So I'm going to write it here: single, double, and triple. And I'm sure you can compare strength between these 3 types of bond. Triple bond is the strongest because it acts like 3 times of single bond. Then double bond and weakest type of bond belongs to single bond. So strongest bond belongs to triple bond. And sometimes we are going to talk about the bond distance or bond length between these 3 types. So we are going to say the shortest bond length belongs to strongest bond, because elements can attract by each other. But I don't want to confuse you. So strongest bond or shortest bond length belong to triple bonds. Right now, I'm going to work on Lewis structure of molecules when we have more than two elements, diatomic molecules. How about H2O? How about NH3 and CCl4, H2CO, CO2? How about if we have ions, NH4 plus or NO2 1 negative, CO3 2 negative. So we should be able to draw Lewis structure for these elements. As you see here, we have more than two elements. They are not diatomic. To answer one possible question, how to get that one, we should start. So you can easily apply the method. I already talked about this in the previous slide, connect the single electrons. But this is a systematic method. I'm gonna work on this and I may ask you to please pay attention. We do have several exceptions for elements, for compounds, but here I'm gonna work on the systematic method that you need to learn and apply for our class. So first, we need to find total valence electrons. Second one, make a bond between the central atom and terminal atoms. And let me call that one bonding electrons. And number 3, we are going to calculate non-bonding electrons by one easy calculation, total minus bonding electron. We are going to know what does that mean. So let me start with one simple example. So I'm going to work with this example, CCl4. First, we need to calculate total valence electrons for this one. Total valence electrons, carbon, group number 4, and chlorine, group number 7. But we have 4 chlorine, so we multiply by 4. So 4 plus 28, we are going to have 32 electrons. So this compound, CCl4, has 32 valence electrons. Again, group number for each one, because we have 4 chlorine, we multiply by 4. So 32 is total valence electrons. So total valence electrons means 32 electrons. Second step, make a bond between central atom and terminal atoms. What does that mean, central atom? Central atom is in one atom, we have only one in the formula. C, it has one, chlorine has 4. So 1, it means central atom. But in general, I'm going to say that if you have carbon atoms, carbon, most likely this is the central atom. So if in the formula you have carbon atom, carbon is the central atom. And how about the other atoms? We call them terminal atoms. So any other elements, any other atoms, they are terminal atoms. In general, hydrogen and halogens are terminal atoms, are terminal atoms, are terminal atoms in our compound. For the central atom, if we don't have carbon, we need to select the elements are placed on the left side of the periodic table. Left side of the periodic table. For example, if we have like this one, HCN. So hydrogen always is terminal, is terminal. Carbon and nitrogen, I told you, look at the formula. If you have carbon, carbon is a central. So you should pick carbon as a central atom. But if you forgot that, so you may say between carbon and nitrogen, which one on the left side of the periodic table? So you may pick carbon atom. So they are something you should know about this side. Right now, I'm gonna draw CCl4, carbon as a central, and 4 chlorine atoms on each side, on each side. And I'm gonna make a bond between the central atom and each terminal atoms. Terminal atoms means chlorine atoms here. So I'm going to draw central, and they are chlorine atoms are terminal atoms. I'm gonna make a bond between them. I'm gonna make a bond between them like this. One bond here, one bond here, and one. So I made four bonds. I made four bonds. So bonding electrons means 2, 4, 6, 8. I made four bonds. Each bond has 2 electrons. It means I have 8. I used 8 electrons here. So to calculate non-bonding electrons, you just need to subtract 8 from 32. So you are going to get 24 electrons. What does that mean, 24 electrons as non-bonding electrons? You need to add non-bonding electrons to terminal atoms. So add non-bonding electrons to terminal atoms and the central atom. What does that? So 24 electrons should be added here. I should start with terminal atoms. So I need to add 6 electrons to chlorine. Why do we need to add 6? Because chlorine has 2 electrons here. So we are going to add 3 pairs here to make totally 8 electrons. 2, 4, 6, 8. It's going to follow octet rule as well. So we need to add 6 electrons to each one because they already have one bond. So I'm going to do that. If we have hydrogen, we don't add because hydrogen has 2 electrons. So we are going to work on this in the next example. I added electrons. Let me count electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I added all 24 electrons here. If we have remaining, we add to the terminal, but there is no remaining electrons. So this is the Lewis structure of CCl4. I'm gonna double check to make sure our central atom follows octet rule. For look at the carbon 2, 4, 6, and 8. So it looks carbon atom follows octet rule. So it means we are done with this example, and this is Lewis structure of CCl4. In the next slides, I'm gonna work on a couple more examples, and we are going to have this strategy for every single compound. Let me continue by working on another example. So let me work on NH3. So we are going to draw Lewis structure of NH3. First, I'm going to set up the total bonding and non-bonding electrons. I'm going to calculate that. For total bonding electrons, you just need to say 5 because nitrogen group number 5, and we have 3 hydrogens. Each hydrogen has 1 valence electron, so totally 8. So right now we are going to have one first draft or skeleton of NH3, nitrogen in the center, and hydrogens can be placed around the nitrogen atom. It doesn't matter you draw hydrogens on the top, left, or right because molecules rotate. In another video, I'm going to talk about molecular geometry and we need to revise. But when we are going to work on Lewis structure, so you just need to draw elements by each side, no matter left or right. Bonding electrons. So I'm gonna make a bond between the central and each terminal. I did that. We just need to count number of electrons. 2, 4, 6. So I have 6 bonding electrons. So to calculate non-bonding electrons, so let me write non-bonding here to make sure no confusion for you guys, and B represent bonding. So you just need to subtract You just need to subtract 6 from 8 means 2. I need to add manually 2 electrons to this compound. We don't add electrons to hydrogens because hydrogen already have 2 electrons, duet rule. So if there is no terminal to add electrons, we add electrons to the central. So right now I added to the central. I'm gonna count to make sure we have 8 valence electrons. So hydrogens, 2 electrons, duet rule, and for nitrogen. So please count with me. 2, 4, 6, and 2, we have 8 valence electrons. So nitrogen is central atom, hydrogens are terminal atom, and in this compound, we have one non-bonding pair or lone pair of electrons. So let me work on another one like H2O. H2O. So I'm gonna set up TBN, total valence electrons, 2 times 1 valence electrons for hydrogen because we have 2 hydrogen atoms plus oxygen group number 6. So totally we have 8. So I'm gonna write oxygen as a central and we are going to have hydrogens like this. I prefer to write hydrogen on the left and right, or we may have a symmetry form. So a symmetric compound, it makes better sense for us. But we do have some calculations, some equations that we need to determine the exact molecular shape. So not purpose of this video. Bonding electrons. So I need to make a bond between central and each terminals. I did that one. 2 and 2 4 bonds. Sorry, 2 bonds and it means 4 electrons. So we are going to subtract to find non-bonding electrons. So we have 4 non-bonding electrons. I have to add first to the terminals. Our terminals are hydrogen. We do not add to the hydrogen. So I'm going to add to the central atom. 2 and 4. So I'm done with adding. So I just need to count number of electrons. Hydrogens have 2 electrons and oxygen 2, 4, 6, 8. So we have 8 valence electrons for oxygen as well. And in this compound, our central atom oxygen has 2 non-bonding pairs here. The reason I'm going to focus on non-bonding of the central atom because in the next video you will see we need to apply one theory, we call that VSEPR theory, VSEPR theory, and we need to do some calculation to get the molecular geometry and shape of the molecules. So I'm gonna give it you a step by step to learn when we draw Lewis structure. What does that mean when we say one bond non-bonding pair or two non-bonding pairs? And last example in this video, I am going to work on this one, H2CO. I am going to draw Lewis structure of H2CO. TBN. Total valence electrons 2. Each hydrogen has 1 valence electrons. Carbon group number 4, 4 valence electrons, and oxygen group number 6, 6 valence electrons. Totally 12 valence electrons. We have carbon and oxygen, 2 hydrogens. So between carbon and oxygen, one must be the central atom. So I told you 2 different methods to know how to write the central atom. One, if you have carbon, always carbon is the central, or you may say between carbon and oxygen, which one is on the left side of the periodic table. So left side, it means more metallic properties. So look at the periodic table, carbon and oxygen, carbon in the left side, it means carbon must be the central atom. So I'm gonna draw like this, hydrogen, hydrogen, like a symmetry, and oxygen here. Again, it doesn't matter how to arrange the elements around the carbon atoms. It doesn't matter at all. compounds rotates. So bonding electrons make a bond between central and each terminal. I did that one. So 2, 4, 6. I'm going to say 6 bonding electrons just use, and we are going to have 6. You just need to subtract 6 non-bonding electrons. We do not add 2 hydrogens, we add 2 oxygen. 6 added here because we are going to have 8 valence electrons for carbon. There is no more electrons to be added, so we don't add any electrons to carbon. I just use all 6 non-bonding electrons here. Then we are going to count number of electrons. Hydrogens have 2 electrons, oxygen 2, 4, 6, 8. Look at the carbon atom, please. We have carbon atom and we have only 6 valence electrons. 2, 4, 6. When your carbon atom, or in other words, in our Lewis structure, if our central atom doesn't have 8 electrons, we have deficiency of electrons for the central atom. If the central atom does not have 8 electrons, we need to remove 2 electrons from the terminals and make a new bond between the central and terminal. Central and terminal. What does that mean? Look here, in this example, our central atom does not have 8 electrons. What should we do? We need to remove 2 electrons from the terminal. So in this example, the only atom, terminal atom has lone pair is oxygen. I need to remove 2 electrons from oxygen. So I'm gonna cross that one. I need to remove these 2 electrons and make a new bond between the central and terminal. So right now I'm gonna make a new bond between the central and terminal. So let me erase that one. Right now I'm gonna count number of electrons for carbon atom. 2, 4, 6, 8. So right now our carbon atom has 8 valence electrons. So look here, 2, 4, 6, 8. So we do have 8 electrons for oxygen. For this compound, we have 2 single bonds and we have a double bond here. So please pay attention to this note. If the central atom does not have 8 valence electrons, you need to do like this step. Last example to finish this video. I am going to ask you to work on HCN. HCN. So we are going to work on this one. H between carbon and nitrogen. Carbon is the central and nitrogen should be here. So let me follow the rule. TBN. Total valence electrons 1, 4, and 5. 4 and 5, 10. So I'm going to make a bond between central and terminals. So I used 4 valence electrons. So I'm going to have 6 non-bonding electrons. We don't add to hydrogen, we add to nitrogen. Then we are going to count number of electrons. I'm done with the 6 non-bonding electrons. I'm going to count. Nitrogen 2, 4, 6, 8. Hydrogen 2. Always we need to pay attention to the central atom. I'm going to count for the central atom. One more time, central atom. 2 and 4. It doesn't have 8 valence electrons. What should I do? I'm going to remove 2 valence electrons from the terminals and make a bond here. So let me remove here. I'm going to count for carbon atoms. 2, 4, 6. we still we have efficiency, the efficiency for carbon. We have not enough electrons for carbon atoms. 2, 4, 6. So we need to do this step one more time. If it doesn't follow octet rule, if it doesn't have 8 electrons, we need to remove 2 electrons from nitrogen and make a bond here. Right now we have 2, 4, 6, 8. So right now HCN has this Lewis structure. In another video, I'm going to work on more examples to make sure you get that one. I'm going to work on cations, anions, and working on a couple more concepts in another video. Thank you for watching this quick review regarding the Lewis structure of compounds.